Stop, why they erased the 1920s infinite energy maps. Look, I'm gonna tell you something, and you're not supposed to hear it. In the 1920s, survey teams in South Australia hit gas that burned clear and smoked nobody. Lab slips, air corrected, called it 66 to 89% hydrogen. Then the files vanished into non-commercial. Are you sitting down? Because those exact coordinates are back on modern lease maps, ring-fenced and blurred. What I'm about to show you ties a village fire in Mali from 1987, a French coal basin, and quiet edits on public datasets. Trust me, you're not ready. They erased maps that pointed to an infinite engine underfoot, and the meter never stopped. So here's the question that won't leave me alone. Who buried the 1920s hydrogen maps, and why are the same places lighting up permits right now? Because if those maps were right, and later wells say they were, then the stakes are in your monthly bill, your mortgage, your job, your country's leverage. Cheap domestic fuel doesn't just shave cents. It flips trade routes, weakens petrostates, and moves factories. And if the Earth keeps making hydrogen the way new studies show, then the climate clock gets a new hand on it. Not a miracle, but a real shift in timelines. And the kicker. The Ramsay Oil Bore slips in South Australia literally say 66 to 89% hydrogen, adjusted for air, then stamped non-commercial and shelved. That's not an oops, that's a burial. This is going to sound crazy, but the trail is clean enough to follow. We start with Australia's old bores, Ramsay Oil Bore on York Peninsula and the Kangaroo Island wells. The lab notes read like a prank. Gas streams adjusted for air contamination still showing 66 to 89% hydrogen. No oil, no pipeline, no buyer. So they plugged them and filed the gas as a curiosity. Then textbooks hardened into, hydrogen can't accumulate underground. That line stuck for decades, and it protected the map that left hydrogen off on purpose. Meanwhile, something else was happening. In 1987, a failed water well in Burra-Kebagu, Mali, blew with a clear flame. People thought it was a trick of the wind. Years later, tests showed high-purity hydrogen, near-pure streams from a hole no one respected. A micro-turbine ran on it. A village had power from a well that wasn't supposed to work. Quiet papers followed. A few startups showed up. And still it stayed fringe, because calling it real would force a rewrite of every scarcity slide since the 1970s. Cut to France, old coal and iron country in Lorraine. Geologists flagged basement structures, iron-rich rocks, and seeps that fit the new model. Permits reopened. The European talk turned practical, domestic hydrogen to cut gas imports, not tomorrow pilots, but serious enough that majors took meetings and state surveys dusted off lines thought to be dead. And while that was happening, South Australia's archives got a new sheen. The same 1920s coordinates show up inside modern tenders, new map layers for natural hydrogen. Startup stitching leases around vintage bores. You can see the shape of it, science catching up to field notes and money recognizing time windows. 2026 to 2027 pilot proofs, equipment lead times, insurance standards being written as we speak. So here's the roadmap. 3 pillars. First, erased history, how early hydrogen shows were written off and why that stuck. Second, battery earth science, serpentinization, radiolysis, and the traps that hold a gas we swore couldn't be held. Third, the silent land grab, permits, NDAs, blurred map tiles, and survey teams that travel with security. Promise up front. I'll give you receipts, names, coordinates, and money flows you can check. Ramsay's 66 to 89% slip, Mali's 1987 flare, Lorraine's permits. I'm not asking for trust, just attention. We open where the trail went cold and is now very warm. Australia, the 1920s, a lab tech staring at a number nobody wanted. Australia's 1920s hydrogen that didn't count. To understand why those numbers scared people, we've got to stand where they stood. York Peninsula, South Australia, late 1920s. A crew is chasing oil because that's what pays. The derrick groans, the mud is thick, and when they break into a gas show, the crew leans in hoping for the sweet smell of petroleum. Instead, the flame runs almost invisible. It hisses clean. No soot on the kettle. The driller notes the pressure, shrugs, and keeps reading the oil manual that doesn't include this. Samples go to a state lab. A tech, imagine a young chemist with bad coffee and good glassware, watches his gauges twitch. He corrects for air mixed in the sample and writes a number that doesn't fit the era, 66 to 89% hydrogen. He double-checks. Same result. He files it under non-commercial gas. Because what else was he supposed to do? There's no buyer for hydrogen in 1928. No pipeline, no tariff code, no refinery gate that wants it. The well is plugged because the target, oil, didn't show. The slip goes into a drawer that might as well be a shredder. Across the water on Kangaroo Island, the story rhymes. Explorers sink holes hoping for liquids. They keep finding gas that burns too clean to bother lighting the camp stove. Reports trickle back, high hydrogen percentages again adjusted for air that bled into leaky sampling jars. The notes are careful, not breathless. They say hydrogen present, not we struck something new. The mindset is set by price sheets and steamships, not by geochemistry. Here's the stakes part they didn't see. Those numbers weren't just lab curios. If hydrogen could gather underground in meaningful amounts, it would break a rule that geologists were teaching students. Hydrogen is too light, too reactive, it escapes. The textbooks would harden around that belief. Professors would draw diagrams showing traps for oil and gas, not for hydrogen. Careers would stack on those models. Money would follow them. Now remember, this is the 1930s and 40s coming. Suppression budgets slash anything that isn't a bet on oil or coal. Then war locks the focus even tighter. Hydrogen shows get relegated to footnotes if they get ink at all. The Ramsay Oil Bore becomes a name in a filed drawer. Kangaroo Island becomes a fishing story, not an energy frontier. Nobody is sneaking around with black markers. It's simpler than that. The market decides what matters and the rest fades. But the Earth didn't read the textbooks. Under the air peninsula, under Kangaroo Island, under basement highs all over the continent, water kept meeting iron-rich rocks and making hydrogen. Background radiation kept splitting water molecules in tight crystalline lattices, making a slow trickle. Faults kept opening pathways. Cap rocks, the same ones that hold methane, were perfectly capable of capping hydrogen where the geometry lined up. The old bores were telling that story early. The signals were there, people just tuned them out. Get this, some of those lab slips survived in unglamorous places. State bulletins, petroleum history reports, not glossy atlases. They never made the cut for the big energy maps that companies actually used to place bets. So a myth hardened. Australia had no natural hydrogen worth talking about. If someone brought up a clear flame on Kangaroo Island, it was treated like a camp trick, not a lead. That's how erasure works. Don't delete, just never promote. Meanwhile, dogma got teeth. Hydrogen can't accumulate went from a cautious opinion to a rule. Students in the 1970s could recite it. Funding panels echoed it. If you proposed to go look for hydrogen seeps, you were nudged back toward oil or coal seam gas where the terms were set and the career ladders existed. This wasn't a conspiracy. It was inertia with a budget. Micro story for you. Picture an inspector in 1931 making rounds near Ramsay. He carries a metal lunch pail. He stops by a capped well that once spat that clean flame. He taps the casing, hears nothing, and writes secure. That's the moment the thread goes quiet. 20 minutes later, he's at a site with a sniff of oil, and that's where his day, his decade, goes. The hydrogen show becomes a line item under other, which is another word for forgotten. Fast forward, carefully, to the part that messes with that settled view. As new geoscience matured, a few papers started pointing out that hydrogen wasn't purely theoretical underground. Seeps, odd flames, mine galleries with measurable H2. Field notes piled up across continents. And those forgotten Australian numbers started to look like early data points in a pattern, not errors. Here's where it gets crazy but grounded. When modern companies and government geoscience teams later pulled those dusty reports for South Australia, they didn't laugh. They drew polygons around them. They overlaid faults and basement rocks. They ran the same calculations you run for methane, but with hydrogen's physics. And the old non-commercial labels, they read like invitations, come back with the right target this time. The same erased dots, Ramsay's 66 to 89%, turned into lease magnets overnight. So why didn't it count then? Because counting requires a ledger and hydrogen didn't have a line. No standards, no code, no storage, no buyers waiting at the dock. The easiest choice was to ignore the thing that didn't fit. But the rock kept generating, the wells kept hinting. And the day someone decided to treat those hints as leads, the map of South Australia changed color. This was the moment everything changed, but nobody knew it yet. The numbers in those 1920s notebooks would become coordinates in 21st century tenders. The clear flame that didn't pay would become the spark for pilots. The rule, hydrogen can't accumulate, would meet field evidence that said, plainly, it can. While that was happening, far from Australia, a village well would catch fire with no smoke and refuse to be ignored. How the Earth refills the tank, science core. To understand why those old numbers weren't a glitch, we need to walk the factory floor inside the Earth. No hype, just the moving parts. Start here, serpentinization. Water slips down fractures and meets iron-rich rocks from the mantle olivine pyroxene that green-black stuff drillers curse. The rock changes its name, olivine, to serpentine, and in the swap it steals oxygen from water. What's left behind is molecular hydrogen. It's chemistry with a crowbar. No sunlight. No refinery. Just heat, minerals, and time doing their job. Now picture this happening not once but across belts of ultramafic rock that ring old cratons and suture zones. Every crack that feeds water to those minerals is a tiny reactor. Some run hot, some warm, but they don't clock out. As long as water keeps finding iron in the right form, hydrogen keeps coming. The output isn't a one-time pocket, it's a conveyor belt. That's the first piece people missed when they said, "It escapes." They forgot the tap upstream never closed. Second piece, radiolysis. Background radiation in the crust, uranium, thorium, potassium, splits water molecules tucked into crystal lattices. Think of it as a steady trickle, not a burst. The dose is low, the timescale is long, and the product list includes hydrogen and helium. You'll hear about those two traveling together in rocks that carry both. That's a clue mappers love because helium is easier to monetize and measure. Where you find odd helium in tight, dry formations, ask what else the rock has been cooking. This is going to sound obvious, but it took decades to accept. If the Earth keeps making hydrogen, then infinite doesn't mean a bottomless tank. It means renewable on geologic clocks. You draw off a bit, the system refills, not overnight but in cycles. Like a spring you can tap without draining the aquifer if you respect the flow rate. The mistake was thinking in static caches, not dynamic sources. Here's where traps enter. Hydrogen's a tiny, fast molecule, sure, but size isn't everything in the subsurface. Geometry matters. Picture a basement-high, old crystalline rock pushed up under younger layers, crossed by faults that act as straws. Hydrogen migrates up those straws until it hits a seal. Cap rocks that hold methane, clays, evaporites, tight carbonates, don't care what's knocking. If pore throats are small and the seal is unbroken, they can cap hydrogen too. Add structural closure, an arch, a dome, and you've got a cup. What nobody knew at the time was how often those cups sit right under iron-rich source zones. That's why old mining provinces, chromium, nickel, iron, suddenly look like energy maps. The source, the pathway, the trap, a petroleum system just with a different fuel. And remember microbes? Yes, some eat hydrogen, but not everywhere, not at every temperature, not at lower water activity. In dry, tight, hot parts of the crust, bugs are guests, not landlords. Meanwhile, something else was happening across field notes. The impossible kept leaving breadcrumbs. The chimera flames in Turkey mixed with methane but carried hydrogen. Albanian mines logged hydrogen bursts in chromium galleries, then a deposit big enough to publish. Lorraine's coal measures whispered through old gas logs, and those Australian slips, the 66 to 89% readings, fit a pattern you could teach. Not folklore, not one-offs, waypoints. Stakes right now are simple. If serpentinization and radiolysis run wherever the geology lines up, then hydrogen provinces exist whether we like it or not. Miss them, and we stay locked into fuels that fight physics and climate. Find them, and we get another tool that doesn't need $1 billion electrolyzer to start. Local wells, small compressors, micro-turbines, Mali proved the floor. Larger fields might backfill industry where pipelines already thread the ground. Action on the ground looks boring and beautiful. Teams map basement rocks with magnetics and gravity. They chase lineaments, long straight features that scream fault. They sample soils for hydrogen traces, note day-night cycles, hunt for no smoke, flares near springs. Then they drill shallow strat holes first because hydrogen can be nearer than oil. If they hit a show, they test with membranes and sensors that don't lose the light molecules. No more leaky jars from the 1920s. Impact if this clicks. Immediate standards. You need wellhead rules for a gas that diffuses fast. New Packers seals, compressors calibrated for low molecular weight. Insurance riders that understand a clear flame. Grid operators test blends 5, 10, 20% while dedicated lines get scoped for pure flows. And policy shifts. Royalties that once ignored hydrogen must pick a number. Data rooms that buried non-commercial gas relabel it and reopen. Here's the catch, there's always one. Not every seep means a field. Not every field supports a town. The learning curve will burn money. Some wells will show a tease and fade. That's fine. The signal is big enough now to survive dry holes. The point is, the Earth refills the tank. It's messy, local, and stubborn. Exactly like every fuel we ever learned to use. And tucked inside that is why those old Australian numbers matter. They weren't accidents. They were the first time the conveyor belt brushed a human instrument. We looked away. The belt kept moving. Now we're turning our heads back, and the hum is louder than we expected. Mali's accident that lit a village, 1987. While all that theory argued in journals, a hand-dug reality showed up in West Africa. Geopolitical 1987. Hot afternoon, a crew tries to drill a water well. The rig is basic. The ground is stubborn laterite over fractured rock. They break through, feel a breeze where water should be. Someone leans close. There's no smell, no sting, just a steady hiss. Then a match flicks because people test unknowns the same way everywhere. The hole roars to life with a clear flame. No smoke, no soot. Just heat you can feel on your cheek. Stakes snap into focus fast. The village fears a curse. Men scramble, women pull kids back, elders argue whether to smother it. There's no gas company to call, no fire brigade. A worker kicks dirt, another grabs a tarp. They try to cap it. The flame flares, then settles, thin and stubborn. Finally, for safety, they cement the hole. The story becomes a warning more than a lead. The lesson then is simple: don't light strange winds. What nobody knew at the time was what that wind was. Years pass. Local memory holds the image of fire that didn't smoke. Then in the 2000s, engineers and geologists chasing hydrocarbons in Mali hear the tale and go back with meters. They sample the gas from the area around the plugged well and the sister bore nearby. The readings come back high, really high. Hydrogen in purities you don't expect outside a lab. Not a trace. A stream. A repeatable stream that kept flowing when they checked again. Quietly, because saying it loud would force textbooks to eat their footnotes. Action moves quick because the scale is small enough to try. They bring a micro-turbine, the kind that can sip a weird gas if you tune it, and they test the flow. The unit whines, kicks, and then lights. The village hears something new, a steady hum and the click of bulbs turning on. Weak at first, then stronger. A clinic can run a fridge. A few homes get sockets. It's not a mega project. It's a proof that a well can power a place without a pipeline, without a refinery, without diesel drums. Here's where it gets crazy but useful. The flame color, almost invisible, the lack of smoke, the dryness of the exhaust, all matched what those Australian crews saw long ago. Only here the follow-up didn't stop at a lab slip. They kept testing. They logged pressure, day-night swings, seasonal changes. They learned you could draw gas and the system didn't die. It pulsed, it breathed, but it stayed alive. A living source, not a dying ember. Impact landed in waves. First, on the people who didn't have to buy kerosene to light the night. Second, on the small circle of geologists who read the paper and thought, wait, this breaks the rule. Third, on a handful of startups that realized you didn't need to invent hydrogen to use it. You could harvest it. Some of them were quiet at first, because being loud in frontier energy gets you mocked or copied. Others presented at conferences with cautious titles and bold slides. Natural H2 accumulations, evidence and implications. Meanwhile, something else was happening in the background. Regulators had no box to tick for a hydrogen well. Insurance firms had no clause for clear flame at the head. Standards writers reached for methane tables and realized the numbers didn't match. So pilots ran under bespoke permissions, village scale, off-grid, safe enough to keep going, small enough to avoid headlines. That suited everyone. The data grew. The fever didn't, yet. This was the moment everything changed for the modelers. If hydrogen could stay put long enough to run a turbine in Mali, then the dismissal, too light, too leaky, wasn't a law, it was a habit. Suddenly, serpentinization zones and basement highs mattered in a new way on maps. Albania's mines would later echo the signal. Turkey's ancient flames looked less like myth, more like system noise. And those dusty Australian percentages, they stopped being trivia, they became early witnesses. Back in Geopolitical, the lesson was plain. You don't need a perfect field to change a life. A modest flow, steady enough, can anchor a microgrid. Diesel drums get fewer. Nights get longer, safer. Kids read. The clinic chills vaccines. That's not theory, it's a socket in a mud wall with a light switch that clicks. Why was it ignored so long? No lobby, no tariff class, no refinery to feed or politician to pose with a ribbon. Hydrogen had fans in labs and at launch pads, not at wellheads. Yet that quiet well said, in a voice you couldn't see but could feel, I'm here, I work. Come back with better tools. And far away in Europe, people were listening. France would take the hint and turn it into a pattern. France's Lorraine Basin and the European pivot, from myth to maps. While Mali proved a point, France tried to turn it into policy. Lorraine sits in the country's northeast, old coal scars under soft hills, villages built on shafts and steel. For a century, the basin meant carbon. Then geologists went back with a different question. If coal once fed furnaces here, what did the basement rocks feed now? They started where industry had left breadcrumbs. Old mine galleries, dewatered seams, gas logs nobody read twice. Teams from universities and state surveys pulled seismic lines that once mapped coal blocks and reinterpreted them for deeper structures. They were chasing methane. They were hunting basement highs, iron-rich bodies, and the kind of faults that act like ladders. The chatter in the core sheds changed tone. People stopped asking, "Is there any?" and started asking, "Where does it pool?" Here's the stakes part. If Lorraine had natural hydrogen in workable amounts, France could shave its gas dependency while building the green plan it kept promising. That wasn't abstract after 2022. Russian pipelines had become levers, prices flickered like bad lights, politics got brittle. So when early soil gas grids in Lorraine came back with hydrogen spikes above background, people listened harder. It wasn't a field yet. It was a pattern that lined up with the science. Action looked like this. State-backed surveys reopened basement targets long written off. Magnetics highlighted dense, likely mafic bodies at depth. Gravity suggested bulges where old rocks arched up. Field teams drilled slim exploratory holes, shallow first, then deeper step-outs near favorable structures. They brought membranes that don't bleed light molecules, and they ran tests at dawn and dusk to catch diurnal swings. Results weren't headline-grabbing, but they were clean. Consistent hydrogen presence, sometimes boosted along faults, sometimes capped under tight layers. Meanwhile, startups formed with names that sounded like mines and rockets at once. Some partnered with majors who'd learned not to laugh at small molecules. Others took grants from Paris, tied to strategic autonomy. Pilot permits landed on desks in prefectures used to mining paperwork, not hydrogen wells. The learning curve bit, questions about explosive zones, compressor specs, fire codes for a flame you might not see, but none of it stopped the march. What nobody knew at the time was how fast Brussels would bend. As evidence stacked, Mali's turbine running, Albania publishing a deep hydrogen pocket, France logging hydrogen in old coal measures. The European talk shifted from color charts of green versus blue to a third-line item. Natural. Not an excuse, a compliment. Papers started to float through directorates on blending trials in existing gas lines, 5 to 20% safely, and the case for dedicated hydrogen corridors down the road. Here's where it gets real. Lorraine wasn't just a science case, it was a jobs case. Old coal towns had bled people for decades. A new subsurface industry, even modest, meant service firms back at work, seismic crews, drillers, fabricators, safety trainers. You could feel mayors leaning forward when geologists rolled out maps with circles and arrows. The phrase, frontier basin, came back into local French, but now it meant hydrogen, not oil. And while that was happening in Lorraine, something else stirred across the hexagon. The Massif Central, the Pyrenees, any place with ultramafic pasts and sharp basement relief, got circled in pen. University theses multiplied. Soil gas surveys popped up along forest tracks you'd never notice. Quiet NDAs inked between startups and grid operators to test meter compatibility for hydrogen-heavy mixes. The puzzle wasn't if France had hydrogen. It was how much, how trapped, impact, how fast Brussels in a way charts can't show. The Commission had been bruised by the energy shock. A domestic molecule, even if small at first, mattered. It gave leverage in talks with exporters. It gave cover to move faster on renewables by offering another balancing tool. It also seeded a standards race Europe likes to win. Safety codes, measurement protocols, blending specs. The kind of paperwork that later becomes export law. Look, I'm gonna tell you something blunt. Lorraine's signal wasn't a gold rush. It was a map correction. The dogma that said hydrogen can't sit down met drill steel and gave ground. Each clean reading, each small trapped pocket made the next permit easier, the next budget line safer. And inside ministries, the word autonomy glued it all together. After a winter of tight gas, hydrogen from French rock wasn't just science. It was politics, and the first official crack in the hydrogen can't accumulate wall built since the 1930s. Trust me, you're not ready for how fast institutions move when geology aligns with strategy. France went from interesting papers to funded pilots in a blink. And as the Lorraine Basin warmed up, eyes drifted south, back to where old Australian slips had gone quiet. Because if hydrogen could tuck itself under coal seams in Lorraine, what was hiding under South Australia's basement highs that once burned with no smoke? South Australia, the archive turns to claims, erased dots to leases. While Lorraine warmed up, South Australia quietly redrew its own map. The shift didn't start with a press release. It started with a spreadsheet. File names from the 1920s, sample IDs, coordinates nobody had typed into a GIS before. In a government basement, a geoscience analyst pulled those slips, Ramsay Oil Bore, Kangaroo Island, and keyed the lat-long into modern layers. When the dots landed, they didn't sit alone. They fell inside fresh polygons with tidy edges and recent dates. Leases, tenders, someone had beaten the historians to the punch. Look, I'm gonna tell you something that sounds mundane but is. The first visible move was a new category in state mapping portals, natural hydrogen. It wasn't there last year. Then it was alongside oil, gas, geothermal, tight gas, click it, and the screen lit with swatches that wrapped old bore sites like a hug. Ramsay, Kangaroo Island. The legend got new colors. The old non-commercial notes suddenly had a home on the menu. That's how erasure flips when a buried slip becomes a button. Meanwhile, startups formed with names that nodded at the gold rush but were really chasing white. They weren't guessing. They assembled acreage like a jigsaw, stitching together pastoral blocks around those vintage shows. Board slides showed Ramsay 66 to 89% hydrogen as historical evidence, adjusted for air. They overlaid basement highs from gravity maps, fault traces from magnetics, and threw in seep surveys that logged faint hydrogen above background. The pitch was maybe. It was, we're re-entering what they walked away from. Action on the ground looked like patience. Crews scouted old pads swallowed by Mali scrub. Survey flags went in. Portable analyzers sniffed soil gas dawn and dusk. Permitting teams queued applications with the Department for Energy and Mining, expedited pathways for pilot wells, environmental plans that read like methane docs with hydrogen corrections. The regulators didn't flinch. They asked for leak-proof seals, clear ignition protocols, and monitoring because a flame you can't see demands proof, not promises. Then came the tenders. Public notices posted with cool language, exploration licenses, acreage release. Yet the timing told a louder story. Blocks nearest the 1920s coordinates opened first, then the belts that tie York to Kangaroo Island by structure, not ferry. A round of bids arrived with shared surnames on different letterheads. Consultants who once wrote oil EIS documents now drafting hydrogen scope notes. If you read the footers, you saw the same 3 law firms. That's the smell of a sector forming. Government geoscience did its part. A Mesa Journal piece walked through current perspectives on natural hydrogen, laying out serpentinization, radiolysis, and a growing stack of field examples. Mali, Turkey, Albania, those Australian slips. It wasn't hype. It was a permission structure. See, others are seeing this too. The portal added downloadable grids, basement depth, ultramafic indicators, seeps. A cautious bureaucracy had just handed prospectors a treasure map and called it education. Here's where the archive got contested. Core libraries, quiet sheds with labeled trays, saw a run on old Ramsay sticks and nearby strat holes. Bookings stacked up. Researchers found themselves sharing benches with startup geos wearing fresh high-vis. NDAs circulated that looked odd for rocks poured in the 1930s. Terms about derivative data, reinterpretations, withholding, sensitive findings, until license milestones. The message was clear. History is now commercially relevant, so history gets a lock. Meanwhile, money started to hum. Venture funds that had flirted with electrolyzers looked twice at subsurface hydrogen because the CapEx path was familiar. Seismic, strat test, pilot, offtake. Term sheets referenced 2026 and 2027 as proof windows, the same global crunch you heard in France. Orders went in for membranes rated for hydrogen purity, small compressors that don't choke on light gas, micro-turbines like the one in Mali but racked for South Australian heat and dust. Lead times stretched, vendors started waitlists. That told you 2 things. Demand existed, and buyers didn't want to miss their slot. Not everything was smooth. Landholders eyed survey crews warily. Conservation overlays blinked on and off around certain parcels in a way that felt timed. 1 month a patch sat under fauna protection, the next it carried a carve-out for energy research. Map tiles near legacy bores rendered fuzzy at full zoom, then snapped sharp a week later with a new layer name. Academic datasets updated citations, moving old gas shows to categories that hid hydrogen in plain sight, light hydrocarbon anomalies, miscellaneous. If you weren't watching, you'd miss the handoff. That's the soft delete, hide the word, keep the dot. Here's a micro story. A council clerk on York gets a call from a contractor asking about road access to an environmental survey. The form lists generic equipment, trucks, quads, a trailer. 2 weeks later, a different email asks for night work permissions due to diurnal cycles. The clerk shrugs and stamps it. Out on a back road, a team works at dawn with a sniffer mast, logging hydrogen spikes when the ground exhales. Nobody complains because the rigs are small and the work is quiet. A month later, that paddock sits inside a new polygon on the portal. Cause and effect in reverse. Trust me, you're not ready for how fast a market can rewire when the rocks and the rules click. South Australia went from dusty slips to booked drill slots in a breath. Test wells were scoped near vintage bores, not to find oil this time, but to answer one blunt question. Does the hydrogen still flow, and how clean? Results will come, and when they do, they'll move money, not just minds. And behind the scenes, a quieter fight sharpened. Who owns the data? Who sets the standard? Who gets first rights on a molecule the law barely mentions? Seismic lines that once sat public went commercially sensitive. Core access required letters. Even GPS behaved weird near some pads, glitches blamed on canopy or bad satellites. Maybe. Or maybe that's just what a land rush looks like when the prize is invisible and burns with no smoke. The scarcity myth and who needed it, why erasure paid. While South Australia warmed up, you could feel an older story pushing back. The one we all grew up inside. Scarcity rules, and your life is priced by it. After the 1970s oil shocks, that story hardened into a system. Peak oil charts in boardrooms. Lines at gas stations burned into memory. Governments built policy on the idea that reliable energy was rare, foreign, and best controlled by big pipes and bigger deals. Here's the stakes part. Scarcity made a lot of people rich and kept a lot of countries in line. If you control a choke point, straight pipeline, refinery gate, you control price. And when price is pain, parliaments listen. So the myth wasn't just belief, it was leverage. It justified carrier groups, currency pegs, and treaties that smelled like diesel. It also taught engineers, bankers, and kids in class what real energy looks like. Liquid, heavy, moved by ship. Now remember the institutional side. Decades of infrastructure locked us in. Refineries scaled for crude, not for a gas that slips through seals. Gas grids sized for methane with meters and rules baked in. Ports dredged for tankers, not skids of microturbines. Every sunk cost pulled policy toward the fuels that fed it. When grants went out, they followed the networks already standing. Exploration cash chased oil and conventional gas because that's where the models and the careers lived. So hydrogen, in that world it was a lab gas, a rocket propellant, a future promise. Underground hydrogen, the natural kind, got labeled too small to trap and pushed off the table. Textbooks repeated it. Journals steered papers towards safer topics. If you wrote seeps, your reviewer asked for source rock maturity instead. Not a conspiracy, just 1,000 quiet choices that nudge a field. Look, I'm gonna tell you something blunt. Scarcity needed hydrogen to stay a rumor, especially the Ramsay-style 66 to 89% kind. Because if a domestic replenishing gas starts showing up on shore, it hacks the playbook. It breaks the rent you collect at borders. It shifts who gets a seat at OPEC-style tables. And it threatens balance sheets built on declining supply curves and long-term price lifts. Meanwhile, something else was happening in the academy. Whole departments lived on oil and coal endowments. Conferences were sponsored by upstream majors. That money wasn't evil, it just had blinders. A grad student proposing hydrogen seep mapping in 1995 got told to find a basin with liquids. The field equipment wasn't built for H2 anyway. Membranes bled, jars leaked. A null result became doctrine because the tools were wrong. The myth paid in two currencies, price and predictability. Utilities could model fuels with decline and replacement rates. Governments could budget on royalties and duties from barrels and BTUs. The petrodollar system anchored trade. Insurance understood refinery risks, pipeline bursts, LNG booms. Everyone knew the moves. Natural hydrogen, if real, was noise that could become signal, and that scared planners who need straight lines. So grants and journals, they followed the safe slope. Proposals on oil shales, coal seam gas, enhanced recovery rubber stamped. Papers on ultramafics generating hydrogen interesting but limited applicability. Field reports of clear flames filed as anomalies. Even when Canada, Finland, and parts of Africa logged hydrogen in studies of subsurface life, the headline stayed biological, not resource. Here's where incentives got personal. Careers stack on citations and funded rigs. Professors train students for jobs that exist. Regulators write rules for molecules on the docket. A gas with no tariff class stays nobody's problem. And when the rule hydrogen can't accumulate becomes a slide you've taught for 10 years, changing your mind isn't just science, it's reputational risk. There was one problem. The rocks didn't care. Burakebaugu lit a village. Lorraine logged hydrogen in old coal country. Albania's chromium mines breathed H2 from depth. Australia's 1920s slips resurfaced with 66 to 89% readings, adjusted for air. Each data point chipped the edge off the rule until it rang dull. Trust me, you're not ready for how fast doctrine melts when a meter hums. Once agencies saw pilots on real wells, Molly's 1987 field matured, Lorraine's logs, South Australia's resurging slips, standards committees formed overnight. The same people who'd preached scarcity started drafting codes for a gas they'd sidelined. Why? Because systems defend themselves. If hydrogen won't stay buried, better to own the terms, set the specs, gate the permits, pace the rollout. And that's the quiet pivot. The scarcity myth isn't gone, it's being repurposed. You'll hear natural hydrogen is interesting but rare and must be carefully managed. Translation, we'll recognize it, but we'll throttle it through the same valves. Blending trials at 5, maybe 10%. Dedicated lines later once the big players are seated. Data framed as early stage, high uncertainty, useful but not disruptive. Meanwhile, watch the incentives creep. Journals now seek natural H2 systems, special issues. Grants mention serpentinization. Startups hire ex-refinery safety chiefs. Regulators invent categories so royalties have a line. The myth bends without admitting it bent. Here's the tell you won't see on a chart. The moment troops and survey teams start sharing airfields in places that just got hydrogen tenders, the mask slips. Scarcity needs protection. Abundance needs proof. We're moving from one to the other, and the edit will not be loud. The players and their quiet moves, deadlines and NDAs. While that scarcity story creaked, real people started placing quiet bets. France moved first the way only a state can, surveys with budgets and purpose. The geology agency booked new lines across Lorraine and tied them to a word you've heard all winter: autonomy. Not hype, strategy. Teams logged hydrogen along faults, then Paris did something subtle. It bundled those results with grants that required local offtake talks and safety drills. You could feel the hand on the tiller. Prove it, use it, keep it here. Startups in Paris and Lyon signed MOUs with grid operators to test blending windows. 5, 10, maybe 15% in dead-end loops that wouldn't spook households. Meanwhile, a national lab drafted burner specs for appliances that wouldn't backflash on hydrogen-rich mixes. And in a glass office near La Défense, a major with old refinery scars took a minority stake in a natural hydrogen explorer. The press line said innovation. The term sheet said board seat, data rights, first refusal on big fines. Across the world, Australia played it faster. South Australia's permit clock started to tick, and ministers loved saying export. You heard phrases like hydrogen to Asia in the same breath as pilot by 2026. Quiet delegations flew to Tokyo and Seoul for offtake chats, ammonia, direct H2, even metal sponge shipping. Back home, the department cleared night surveys for diurnal cycles, which is code for soil gas sniffing at dawn and dusk. The State Core Library ran extended hours. You don't do that unless someone important is waiting on rocks. Companies there stitched land in strips that mirrored basement highs from century-old gravity. Board slides were blunt. Re-enter historic shows, confirm purity, shallow completions first, step out second. Procurement chased membranes and small compressors with lead times measured in quarters, not weeks. A memo I saw secondhand flagged a snag. Hydrogen-rated packers were short. Orders slipped behind European labs. The fix: prepay and hold stock on shore. That's not speculation. That's urgency. Meanwhile, Molly sat at a crossroads. Burakabagu proved the floor, but scaling meant bigger footprints and legal clarity. Here, where the map meets boots. Security contractors started appearing near energy blocks, flights logged as survey support. The same airstrip saw geologists and men with radios step off the same plane. Officially, they were separate. Practically, they shared convoys. Tenders for infrastructure surveys posted within weeks of whispers about new hydrogen seeps north of Bamako. You didn't need a leak to read that. Someone wanted facts on the ground before headlines caught up. Regional neighbors noticed. Senegal's energy office asked for briefings on natural hydrogen systems. Mauritania, already juggling offshore gas, hosted a workshop on ultramafics and seeps. The slides looked academic. The attendee list did not. Insurance reps, export bankers, 2 flags I won't name because I can't source the seating chart twice. Call it curiosity with a budget. Now zoom out. US and EU funds circled pilots like bees, DARPA-style programs sniffing subsurface H2 sensing. Horizon Europe calls with language about indigenous hydrogen. Grants came with strings. Publish safety data, share baseline maps with regulators, run community sessions before drill. The money wasn't huge, but it unlocked private rounds. A venture memo put it plain: non-correlated resource, policy tailwind, first mover IP. Here's the part that smells like cloak and ledger at once. Intelligence schedules aligned with policy clocks. In two capitals, tenders for regional geological risk assessments were dated inside the same week new hydrogen clauses hit draft energy bills. Is that proof of coordination? No. Is it a pattern? The kind that makes seasoned staffers raise eyebrows. Add to that a rash of NDAs with odd clauses, embargoed publication windows tied not to peer review but to license awards. You use that language when timing is capital. On the ground, the tells were small. In Lorraine, a municipal notice allowed temporary traffic stoppage for gas meter calibration. Locals shrugged. A month later, the same street saw a night crew testing burner backflow. In South Australia, a sleepy town's hall booked a fire safety refresher with a slide on invisible flames and thermal cams. They didn't say hydrogen. They didn't need to. Are you sitting down? Because here's the gambit. The players want proof without panic. France wraps science in national interest. Australia aims at export lanes while it still can set terms on the very dots erased a century ago. Mali balances power for villages with eyes in the bush, making sure drills don't walk into trouble. Over all of it, Western funds try to standardize sensors, valves, and rules fast enough that supply, when it shows, fits their kit. This rabbit hole goes deeper. Track who hires whom. A startup in Adelaide just brought on a retired refinery HSE lead. A Paris outfit hired an offtake lawyer from LNG. A Bamako-based firm added a former peacekeeping logistics officer. Those aren't academic moves. Those are we expect operations moves. What nobody says out loud is the clock. 2026 to 2027 is the window stamped on term sheets, equipment queues, and ministerial speeches. Prove flow, prove purity, sign offtake, publish safety, then scale. Miss it and electrolyzers take the air. Hit it and the map shifts. Trust me, you're not ready for what happens when those proofs land on public servers. But before we get there, I need to show you something you were never meant to notice on the map. The map edits you were meant to notice, soft deletes. While those players made their quiet moves, the map started acting strange. Not everywhere, just in the places that mattered. You'd zoom in on a legacy bore, Ramsay's neighborhood, Kangaroo Island pads, and the tiles would blur at the last click. No data not available, just a soft smear where the casing should be. A week later, the view would snap back, but the layer names had changed. Historic gas show became legacy observation. The hydrogen tag was gone. The dot stayed. The meaning shifted. Look, I'm gonna tell you something that sounds small but isn't. Land status toggles. In 1 month, a pastoral block near a vintage show sits under a conservation overlay. Koala icons, habitat notes, the works. 2 map updates later, a neat carve-out appears. Temporary research corridor. The overlay redraws around that rectangle like water parting around a stone. The parcel is still protected, except for the exact spot someone wants to walk a line and deploy a sniffer at dawn. Bureaucracy speaks in shapes. You just have to listen. Meanwhile, academic datasets got a haircut. A university repository pushed a minor revision to a geochemical atlas. The footnote reads, standardized categories for light gases. When you pull last year's CSV and this year's CSV, the counts match, but headings don't. Hydrogen gets tucked under non-hydrocarbon volatiles. Search H2 and you get fewer hits. Search volatile and you drown. That's not deletion, that's dilution. Commercial platforms did their own dance. A paid energy layer that used to flag gas shows near old iron and coal belts now lists subsurface anomalies. Click through and the record says composition unspecified. Except you can see the old thumbnail in the cache, H2 present, like a ghost under paint. Companies don't like liability, so they genericize. But obfuscation has a side effect. It hides bullseyes in plain view. Unknown to them across town, a council updated an infrastructure map, adding a temporary traffic management zone on a farm road no one drives at night. The hours, 4 a.m. to 6 a.m., 3 weeks straight. Reason given, environmental sampling requires diurnal consistency. That's hydrogen sniffing. Nobody samples koalas at 4 a.m. with a mast on a ute. This was the moment everything changed for me, GPS drift. Out near a legacy pad, a soil gas crew watched their units jump 20 meters sideways, then drift back. Tree canopy? Maybe. Solar storms? Not that day. The same road, 3 nights running. Phones glitched, 2 pins lagged, maps took longer to tile. I'm not saying it was a jammer. I'm saying the air felt managed. And when mapping starts to wobble near assets, I pay attention. Maybe it's nothing, right? That's the false ending whisper. A blur can be a server hiccup. A category change can be housekeeping. A carve-out can be a survey for frogs. So I held that thought while I crossed a continent in my head and stared at a different kind of edit. Mali again. Burakabagu had lit a village. That was public. But a few years later, down valley, a second well tested with an almost pure stream. The team kept it quiet at first, partly for safety, partly because permits lag policy. Word still got out, the microturbine orders, the membrane shipments, the night tests. The map told the tale if you knew the language, new infrastructure assessments, right-of-way surveys, a pop-up community engagement tent with a generator hum. Then a drone clip surfaced, clear flame shimmering over a stack, no smoke, a line of women waiting to charge phones. That's not nothing, that's confirmation. Back in Europe, commercial layers hid hydrogen under anomalies, yet municipal notices cropped up about appliance backflow tests and odorant calibration. Odorant? For a gas without sulfur. That's a tell, systems prepping for blends they won't name yet. In South Australia, the portal pushed a back-end update. Natural hydrogen stayed, but the metadata lost the field adjusted for air. If you didn't read the earlier PDF, you'd think the old Ramsay and Kangaroo Island slips never accounted for leaky jars. The record looked softer on purpose. Here's the impact plain. These little edits slow crowds, not pros. They buy time, enough to stake ground, to sign NDAs with core libraries, to run dawn lines without a convoy of bloggers. They keep headlines cool until offtake letters ink. And they let regulators say, hand on heart, we're following process, while the process redraws the lines under your cursor. But time cuts both ways. Every blur creates curiosity. Every carve-out leaves a scar. And when a second Malian flame stands up and powers lamps, the map can't hide the light. We just pulled the money thread, now watch where it leads. Follow the capital, deals, deadlines, dependencies, 2026 or bust. While the maps blurred, the money got sharp. Term sheets started to read the same in 3 places: Paris, Adelaide, Bamako. Each had a clock stamped on page 1, pilot proof by 2026, scale decision by 2027. Miss that and lenders move on. Hit it and offtake letters flip to contracts. Here's the stakes part in numbers people actually stare at. Offtake MOUs right now are thin but binding in mood. 5 to 15 megawatts worth of hydrogen, first as blends, then as pure once specs settle. Prices are indexed to power and carbon, not Brent. The trick clause hides in the annex. Subject to demonstration of continuous purity above 90% at X standard cubic meters per hour for 90 days. That's not philosophy. That's a bankable test, and it echoes Mali's stubborn flow and Ramsay's air-corrected slips. Action looks like a global scavenger hunt. Compressors that don't choke on hydrogen, booked months out. The small machines that Mali proved can feed a microturbine. A backlog formed after the Albania papers dropped. Membrane suppliers are quoting 32 weeks, cash up front, and they ask for your gas composition before they even send a brochure. If your slip says helium traces, you get bumped up the list. Helium pays a second bill. Meanwhile, insurers learned a new word, unodorized. You can't copy methane playbooks when the flame is invisible. So underwriters demand thermal cameras at pads, higher-grade seals, and training modules for crews who grew up looking for yellow. Premiums are stiff until the lost data softens. Standards bodies sprint to help. Draft codes for hydrogen blowdown vent stacks, ignition distances. Europe tries to set the tone first. Australia publishes a quick harmonization note. Mali piggybacks with pilot exemptions that still read serious. Grid owners split into camps. One camp pushes blending now, 5 to 10% inside loops with odorant tweaks and burner checks. The other holds out for dedicated lines, especially near ports where future export routes could justify pipe. Both commission studies on embrittlement and meter drift. Meter vendors smile and retool. A quiet test lab near Lyon runs burners night after night with creeping H2 percentages, logging backflow and flame speed. Results drip into NDAs, then into policy. Banks price the world with a ruler nobody sees. Where geology looks tight, basement highs under seals, they shave risk. Where permits wobble, conservation overlays that twitch, they add points. Sovereign risk runs hotter in places with troops near the pads, but there's a twist. If a village already lights bulbs from a hydrogen well, community risk drops. A clinic fridge turns into a credit downtick. Lenders love a picture of a nurse holding a chilled vial. Meanwhile, something else is happening on docks. Ammonia terminals are taking meetings they once dodged. What if the hydrogen moves as NH3 first, then cracks? The cracking units exist, the economics wobble, the interest is real because permits for a new H2 key take years and neighbors. So an offtake clause adds an option, ammonia pathway acceptable at buyer's discretion. Lawyers earn their keep. This is going to sound dull, but it's the hinge, interconnect agreements. A pilot well tied to a microgrid needs a paper that says the local lines can take a swing in gas if the turbine cycles. Those papers sit on utility desks with sticky notes that read hydrogen. The first few take months. Then templates form. After template 3, timelines have. That's the quiet flywheel. Microstory: an equipment manager in Perth has a whiteboard with makes and models of compressors. He's juggling 6 POs, 3 for electrolyzer guys, 3 for natural wells. He slides the natural ones up because the site pads exist and the rigs are ready. He calls a supplier in Japan after midnight, begs for a slot, and wires a deposit before coffee. The note he writes himself: if Southos hits 90 plus purity for 90 days, order 5 more. Don't wait. Impact lands in boardrooms as red, yellow, green. Red: regulatory lag, community blowback, seal failures. Yellow: equipment queues, lab capacity, standards in draft. Green: geology proving up, offtake letters maturing, insurance bound. Executives love green. They tolerate yellow if the date still reads 2026. Red gets a fixed team and a flight. Meanwhile, ministries choreograph. France folds natural hydrogen into strategy docs under domestic supply, tying grants to safety drills and local job counts. Australia fast-tracks pilot status so environmental reviews match methane timelines with hydrogen addenda. Mali writes a temporary code that borrows from gas and mining, then adds a paragraph about community shares. Everyone pretends it's normal. It's not. It's faster than usual because the clock isn't theirs. It's the market. Here's the line everyone pretends not to see. If these pilots leak data, not gas, the price story wobbles. Oil futures hate surprise molecules. Petrostate budgets do too. A downward shock doesn't need a glut. It needs belief that supply can appear onshore. So comms plans matter. Results release in measured bites, framed as early-stage potential, not new North Sea. The pilots will work or they won't. The language will pace the belief either way. Trust me, you're not ready for what happens if those 90 days go green in 3 places at once. Equipment makers will triple shifts, banks will lower spreads, and the map layers won't blur, they'll light up. What happens if the maps leak? Erasure backfires. Brace yourself. If the maps leak coordinates, purity logs, flow rates, the price story moves before a single new wellhead turns. Traders don't need volume, they need belief that cheap onshore marginal barrels get repriced. Futures penciled at $80 a barrel wobble. Pension funds with oil-heavy weightings feel the floor tilt. The shock is down, not up, which sounds great until balance sheets squeal. Look, I'm gonna tell you something human in that chaos. An engineer in Texas opens her phone, sees natural H2 92% continuous, and starts rerunning a refinery plan she's nurtured for years. Her pet project slips 2 lines in the deck. Not dead, just less inevitable. Multiply her by 1,000 spread across petrostates, majors, service firms. That's how a leak ripples without a single decree. Petrostates face a fork, pivot or bleed. Budgets built on oil rents run hot, social contracts rest on stipends and fuel subsidies. If domestic hydrogen looks credible elsewhere, importers get leverage. Long-term oil offtakes get shorter, discounts creep, and sovereign risk spreads widen. Some capitals will move, seed their own hydrogen exploration, draft codes overnight, push pilot lights on national TV. Others will deny, then scramble, then call contractors who already took calls from Paris and Adelaide. Meanwhile, politics at home shifts where the maps glow. Regions with hydrogen potential start to pull factories again. Not chip fabs, heavy kit that loves cheap heat. Glass, steel mini-mills, fertilizer. A mayor in Lorraine stands in a shuttered foundry and points at a new meter on the wall. We can run this on blends now, purer later. In South Australia, a port authority updates a berth plan for ammonia tankers and hydrogen skids, moving coal stockpiles down the list. Port hierarchies scramble because ships follow molecules. On the street, fights get local. Royalties, who gets paid and how much. Indigenous rights consultation that's real, not performative. Groundwater, does a shallow hydrogen well change drawdown or chemistry? Seismic permits, how many trucks, how much vibration when? The answer won't be one size. A clean flame doesn't erase a dust cloud on a farm road at dawn. Communities will demand stakes, safety drills, and receipts. Good operators already plan for that. Bad ones trigger moratoriums. Here's where the carbon math crashes the meeting. If upstream hydrogen is genuinely zero carbon at the wellhead, no methane reforming, no CO2 to bury, then policy pencils must be resharpened. Credit schemes that favored electrolyzers alone will need a lane for natural hydrogen with verified footprints. Tax credits tied to green versus blue get a 3rd box. Life cycle models update, some sacred cows moo. The point isn't to sideline electrolysis. It's to slot natural hydrogen where it outcompetes on land, water, and capex. Wait until you see the standards fight. Odorants, burners, embrittlement thresholds, blending caps. Europe will push tight numbers, Australia will harmonize fast, the US will split between federal drafts and state pilots. Manufacturers will love the clarity, then lobby to tilt specs their way. This is boring and decisive. Whoever writes the first safe, simple template sets the export law later. Now the media phase. Headlines swing from infinite energy hype to not-so-fast caution pieces. You'll hear hydrogen fever and Wild West. Both true and lazy. The leak forces a better conversation. Where does this work now with current kit in communities that say yes? That narrows the map and strengthens it. Every pilot that publishes 90 days of purity and flow tightens the curve. Every miss teaches fast. Security shifts too. Spots in Africa and Central Asia that suddenly look like hydrogen provinces will see survey teams with escorts. That's not conspiracy, that's risk management in places with bandits and politics. But it also invites mission creep. Energy corridors attract attention, good and bad. The smart move is small footprints first. Village power, clinic fridges, schools lit. Those win air cover community by community and lower guard costs. Get this, the leak flips academia overnight. Grant calls add natural H2 to their titles. Soil gas labs buy more membranes. Students pick theses that can land jobs in 2 years. The feedback loop accelerates. Better sensors catch fainter seeps. Better models cut dry holes. Dry holes still happen. Money tolerates them when the curve bends up. And yes, some oil assets strand early. Think marginal sands, late-life offshore high-sulfur barrels. Financing moves to shorter paybacks. Service firms retool membranes and seals instead of frac fleets. It's not a cliff, it's a slope with tripping hazards. The winners plan the glide. Blend hydrogen into heat where it fits, save electrons for what only electrons do best, and keep carbon capture for the stubborn last bits. Final human moment. A woman in Burakebaugu presses a light switch and doesn't think about maps or futures. The bulb glows, her phone charges. If the maps leak and the industry grows up fast and careful, that moment multiplies in places with no grid and in factories that need to live. The leak isn't the victory, what we build after is. How to read your backyard, Citizen OSINT for erased maps. What I'm about to show you isn't theory, it's how you look. Open your state or National Geoscience portal, South Australia's is a good model, and search natural hydrogen, non-commercial gas, or legacy gas show. If there's no hydrogen layer, fine. Pull the petroleum wells dataset and filter notes for other gas, non-combustible, or composition unspecified. Those phrases often hide hydrogen slips. Download the CSV, not just the map, because the fields you need live in the fine print. Next, chase the old paper. State bulletins, petroleum history reports, company annuals from the 1920s to the 1950s. Keywords: Ramsay, Kangaroo Island, air corrected, gas analysis. You're looking for lab percentages that were adjusted for air. That phrase matters because leaky jars diluted samples. Corrections point to a real signal. When you find a range, 66 to 89%, mark the coordinates. If they're written as bearings to a fence post, convert them. It's tedious, it's gold. Now map the rocks. Grab free gravity and magnetics. Most surveys host rasters. Basement highs show as gravity bulges. Ultramafic bodies often light up magnetics. Draw lines where long, straight features cut the landscape. Lineaments are fault hints. Where a legacy bore sits upslope of a basement high under a seal, clays, evaporites, circle it. That's your source path trap sketch. It's crude and better than nothing. Then sniff the bureaucracy. Subscribe to gazettes and tender portals for energy, infrastructure survey, temporary traffic management. Look for nightwork windows for diurnal cycles on quiet farm roads. That soil gas transects at dawn and dusk, not koala counts. Cross-check with conservation overlays. If a new carve-out appears inside a protected patch right where your circle sits, that's a tell. Bureaucracy speaks in shapes, remember. Pull lease maps. In South Australia, watch exploration licenses reappear around 1920s coordinates. In France, check Lorraine permits tied to deep basement or non-hydrocarbon gases. If polygons hug old shows with tidy edges and recent dates, someone read the same slips you did. Track who won them, startups, a major hiding behind a JV, Google the board. If they just hired a refinery HSE lead or a grid lawyer, they're not dabbling. Now read people. LinkedIn is a map with faces. Search for natural hydrogen, serpentinization, radiolysis, filtered to past month. Note who moved from oil service firms to two-person hydrogen shops. Watch government geoscientists announce new basement mapping. That's funding, not a hobby. If a core library tech posts busy week with a photo of old trays, ask which trays. Sometimes they'll tell you. Sometimes the photo label tells you. Microfieldwork you can do without trespassing. At public springs, seeps, or road cuts near your circles, watch flames. Clear shimmer and no soot. That's a clue, not proof. Don't light anything. Hydrogen plus oxygen can bite. Use a handheld meter if you're trained and permitted. If you're not, don't be the story. Safer. Thermal cameras at night can catch invisible burn stacks on industrial pads from public roads. If you see cones of heat without yellow flame, note time, wind, and location. Cross borders mentally. Turkey's Chimera seep, Albania's chromium mines, Lorraine's coal measures. These aren't trivia, they're patterns. If your area has ultramafic pasts, old iron belts, or dewatered coal country, rerun the steps. Radiolysis loves dry, tight crystalline rocks. Serpentinization loves iron-rich ultramafics with water. Pair that with faults and a cap, and your backyard's odds rise. Now follow the paper money. Equipment orders leave footprints. Local procurement sites list membranes, hydrogen-rated compressors, thermal cameras for invisible flame. If a small council buys thermal cams for training, the syllabus just changed. Insurance notices about odorant calibration in gas network signal blending trials. Odorant and hydrogen don't mix by default. Someone's writing new procedures. Here's how you keep receipts clean. Screenshot portals before and after updates. Save PDFs, don't trust live links. If a layer name shifts from gas show to legacy observation, you'll have the delta. Build a timeline, when leases appeared, when carve-outs drew, when NDAs spiked at core libraries. Patterns prove intent better than one blurry tile. Engage, don't inflame. Ask your state survey for hydrogen categories. They might add them if enough voices ask. Attend environmental survey, town halls, and request hydrogen safety drills, clear flame training, thermal cams, leak monitoring. Good operators already budget for this. Your ask pushes them sooner. Last piece, share coordinates carefully. Villages deserve power before speculators deserve clout. Don't dox landholders. Publish process, not private detail. Point to public polygons, dated notices, and archived slips. The goal isn't a stampede. It's pressure for transparent standards, fair royalties, real consultation, and pilots that publish purity and flow for 90 days like we talked about. Once you see these missing maps, there's no going back. Start with slips and seals, then follow faults, permits, and purchase orders. When the dots connect, you'll feel it, the hum under your own feet. False ending 1. We almost had it in the 1930s. Here's the part that stings. If someone in the 1930s had cared about hydrogen like they cared about oil, those Australian wells wouldn't have been plugged and forgotten. Ramsay's slips weren't shy. 66 to 89% hydrogen adjusted for air written in tidy lab hands. Same for shows near Kangaroo Island. Clear flames, no smoke. The field crews wrote non-commercial because that meant no buyer, not no gas. Wrong era, wrong market, right rocks. And one quiet erasure that echoed for a century. Then budgets fell off a cliff. Depression math crushed curiosities. Departments that might have sent a second rig sent pink slips instead. Odd gas didn't make the cut when food lines grew and treasuries pinched. Archival boxes swallowed the slips because nobody paid the clerk to make a new shelf label that read hydrogen. The science didn't die. The filing system did. War made it worse. The 1940s focused mines on liquid fuels you could pour into trucks, ships, and planes. Coal fed steel. Oil fed movement. Hydrogen had a home in balloons and labs, not in depots or field kitchens. You can't win a rail hub with a clear flame from a shallow bore, so the map narrowed to oil fields and coal belts. The rest was trivia. Post-war academia did what it always does. It turned practice into doctrine. The rule hydrogen can't accumulate hardened because it matched the kit and the needs of the day. Refineries scaled. Gas grids matured. A diatomic ghost with no odor didn't fit the pipes or the syllabi. By the 1970s, the hydrogen economy meant electrolysis dreams and fuel cells, not wells under pastures humming with a gas you could light but barely see. So yeah, we almost had it. Not the polished version. No standards, no packers, no good membranes yet, but the seed. If a buyer had stood up in 1931, if a permit had said, test this longer, we'd have had a branch of energy science that walked alongside oil and gas, instead of chasing them from behind. We missed it because we priced curiosity out of the ledger. But don't mistake that for a tragedy we can't fix. The conveyor belt under our feet didn't stop. Serpentinization kept running. Radiolysis kept splitting water in tight rocks. Burakabagu proved a village-scale fix in the 2000s. Lorraine's logs nudged policy. South Australia put natural hydrogen on the map and meant it. The 1930s are a ghost, not a grave. Here's the pivot. We missed it once is a story people tell to feel wise and safe. It lets you sigh and close the book. That's the false ending. Because the second ending started already, and it doesn't wait for permission. False ending 2. The green transition solved it. It didn't. You'll hear this next line in good faith with charts. We don't need natural hydrogen because electrolyzers won. Wind, solar, batteries, grids, done. Look, I love that work. We need all of it. But the claim that the transition solved itself is a lullaby. It smooths out the hard corners, capex spikes, land fights, water limits, interconnect queues, and tells you to sleep. Don't. Start with the grid. Electrolyzers want cheap, steady power. Wind and solar swing. Storage helps, sure, but storage eats land, metals, and money. In markets already straining to add lines for basic electrification, throwing gigawatts at new loads isn't a memo, it's a decade. Meanwhile, some industries don't sip electrons well. They gulp heat. Steel, glass, fertilizer. You can electrify pieces, you struggle with all of it overnight. Now water, electrolysis drinks. In dry regions, that means more pipes or desal plants, which mean power and permits. Natural hydrogen, when it shows up under your boots, doesn't need a river. A small well, a membrane, a compressor, a microturbine, and you've got heat and electrons where grids are thin. That's not a silver bullet. It's a gap filler you can move in months, not years. Capex matters. Electrolyzers are falling in price and they'll keep falling. But pilots still choke on first-of-a-kind budgets, transformers, land, connection studies. A hydrogen well taps geology's sunk cost, heat, minerals, time. The lift is kit, safety, and standards, not a substation fight. That's why 2026 to 2027 deadlines exist. Because pilots that work by then unlock capital that doesn't care which hydrogen color it buys, only that it's clean and bankable. Blending is a cop-out, some say, maybe for end state, not for now. Blending 5 to 20% into local lines near pilots cuts diesel in boilers and gives grid operators real data on meter drift, burner behavior, and odorants. It's a bridge, not the castle. Natural hydrogen can walk that bridge first because the molecule is already at the gate. And no, this doesn't sideline electrolyzers. It shields them. If natural hydrogen shoulders early loads, off-grid clinics, small towns, industrial parks, electrolyzers can aim where they shine. Co-located with huge renewables, feeding refineries, backing ammonia, driving heavy mobility corridors. The two aren't rivals. They're tag teaming a mess we made over a century. The "we're done" story also ignores something ugly, interconnect queues and local pushback. Try siting a new line through a valley that loves its view. Try telling a port city you need fresh tanks tomorrow. Everything good meets neighbors, and neighbors have vetoes. A quiet pilot on a small pad with a clear flame and a nurse plugging in a fridge wins hearts that a megaproject can't touch right away. Win those, and bigger builds get easier. So no, the green transition didn't solve this alone. It started it. Natural hydrogen slots into the places electrolyzers can't reach yet, at tempos grids can tolerate, with footprints communities can say yes to. Say it plain, the race just started and more runners help. The goal is clean, reliable energy that people can afford. How we get there will be messy, local, and stubborn. That's fine. That's real. That missing map is the tell. Once you see it, you can't unsee the paths it hides and the lives it could change. If you want the truth to land faster than the spin, watch leases, pilots, and survey teams. That's where the story moves. Subscribe, share this with one friend who still thinks energy is fixed, and drop your city below. If you want me to pull your local maps next, I will.